of those three conditions is always the next step. So let's follow those literally for the moment. Let's do up equals down and left equals right. So if we look at our force diagram, so this shows you the advantage of having a good diagram. If you've got your diagram done correctly, it becomes very easy now to identify the forces: up, mu, r, and s. So up equals down. And that implies that mu r plus s upwards is equal to the downwards forces, which is W and W 2W. And next, so that's step 1. Step 2 is left equals right. Back to our force diagram. We can read them straight off. Left is R, right is mu s. R equals mu s. And lastly, sum of moments is 0. And applying this to our question, the first thing we need to identify is an axis of rotation. And this is where our lint diagram comes in, because we can read our forces off this diagram. Moments is force by distance, so we read the force off the first diagram and distance off the second diagram. And it makes it all very neat. And let's see, we need an axis first though, and probably the most convenient place to have an axis is usually a point where the most forces go through. And we can see here that if we pick this point here, there's 3 forces going through it. We've got the force W, R, and mu r. So this is a good general rule. Pick your axis as the point that most forces or their lines of action go through. By line of action we mean if this is the force W, the line of action means extend that indefinitely in both directions. And we see that if we do, it goes through that point. Of course, strictly speaking, it's not a point. We're visualizing rotating around an axis coming out of the screen through that point. Okay, so this is our point. Let's call it maybe the point X. So let's get the moment about that point X then. So the moment about the point X, we note it like that, say the word in moments. And we use convention that anti-clockwise moments are plus. So if this is our axis, let's pick out the anti-clockwise forces, the forces that would tend to turn the system anti-clockwise around that axis. And we can certainly, there's only 3 forces left, S, mu, S, and W. So certainly S, if you visualize that rotating, would rotate the whole system anti-clockwise. And it's S, it's the line of action of S by the perpendicular distance to the axis. Perpendicular distance is from here to here, which is A. So it's S by A. S by A is anti-clockwise. Back to the diagram, that's actually it, because the 2 remaining forces would tend to turn the object clockwise. Again, if this is our axis, the force mu s would be clockwise. And the line of action of mu s is along here, and the distance from this line of action to the axis, again, is A from our diagram below. So it's A. So it's mu s by A. Mu s by A, plus there is one more moment. There's the weight, W, again by the perpendicular distance in the axis. So here's W. This is going to turn the object clockwise, and perpendicular distance is the distance from this line over to this axis. So it's this distance here. So again, come down to our lint diagram to see that distance. here to here is actually what we marked off as 2L. So it's W by 2L. And let's just tidy that up, so that's W by 2L. And that's our three equations. Let's put a box around those three, and now it's just up to us to solve them and try and find what we're asked to prove. Now we can solve equation 1 and 2. And we can substitute R into equation 1. And let's see what happens. We get mu into R, which is mu s, plus s is equal to 2W. And we can tidy that up and factorize and get mu squared plus 1 into s equals 2W. And now let's call that equation equation 4. And we'll try and solve that with the third equation down here, and let's try and eliminate s this time, so that from this equation, of course, we can get s on its own, we can isolate s, and we get s to be 2W over mu squared plus 1. And now put that into equation 3 for s. Before we do that, of course, we can tidy up. We can keep all the s's to one side, and we get s minus mu a, or s minus mu. Let's just start that again. We get s into a minus a mu, or sa into 1 minus mu, is equal to 2LW. And for s we put in 2W over mu squared plus 1 times a into 1 minus mu is equal to 2LW. And W cancels on both sides, as does the 2. And we're left with a is equal to multiply across by mu squared plus 1, and you get 1 plus mu squared times L divided by 1 minus mu, which is what we were asked.